Myself, I am Dr. Jntuh. In this class, I am going to discuss with the virtual memory concept of the file system. Virtual memory concept is nothing but it is a storage mechanism which offers the large file amount of memory which can be stored in the main memory. It can be done with the help of the secondary memory and as with the help of the primary memory. As we know that the primary memory is a large one and it is capable of storing the large amount of memory in a long process so that the OS can use that particular process whenever they want in the sequence. Virtual memory is one of the techniques that allows the execution of a process that will not be completely stored in the main memory. It can be stored with the help of the secondary memory. The virtual memory is implemented with the help of the demand paging and demand segmentation concept. Here, the user can store the large amount of process with a bigger file size than the available in the main memory. Major advantage of the virtual memory is that the program can be very larger than the physical memory. This technique frees the programmer from the main memory storage limitation. It allows them to share the files easily and implement the shared memory concept. In this virtual memory concept, the following reasons are handled during the pages of the sequence. The first condition is error handling code will be occur during some of execution of a file or storing of a file that will specify the errors when there is occur in the file storage system. Second criteria, it will be having oversized of file images. So a small fraction of file can be deleted from the particular location. The entire program in this condition may not be stored at the same time. It will be partially divided and stored simultaneously in the frequent periods. So these are the difficulties that are faced while storing in the main memory during the transition of a virtual to a main memory. So the other condition is the virtual memory can having a ability of executing a program partially. So this having some of our advantages as well as the disadvantages. A program which is going to be stored into the particular physical memory, which is always being available to the particular user. So it should be lesser than the main memory. Otherwise, it will increases the CPU utilization capacity and throughput is also increased. Due to this, the time constraint will be very, very large. So this can be having an advantage of it will require very less amount of input output conditions, and it also take many more time for loading or swapping the user program into the main memory. So this can be explained with the help of this diagram. So consider this is a virtual memory that has been transferring the particular memory to the physical memory. Here the separation of pages which has been listed in the virtual memory can be shared with the memory map criteria, and the memory map function is going to share with the physical memory and it is stored in the magnetic disk. The use of the demand segmentation concept, here the particular pages are divided into different segments and it is then correlated and mapped into the physical memory. Moving to the next one, that is virtual address space. The virtual address space of a particular process refers to the logical process that is stored in the main memory. Here the section is divided into 4 different categories: stack, heap, data, and code. So we can view the particular process from 0 to the maximum. It can be stored in the main memory unit, that is memory management unit, MMU, that will capable of mapping the logical page frames into a memory. Here the stack which we are using, the first in first out concept, it will forward the data to the heap. The heap can be able to assign and organize a particular page frames to a particular process that may be a continuous one. So data here is used for moving the code downwards to the memory. So and the code will also be helpful for turning the content of a physical address to a logical address. Here the maximum address space can be used in the virtual address space. So the large amount of blank space will be added in the heap as well as in the stack. And this concept is called as a hole. It is a part of a virtual address space. Holes will appear actual physical pages only if the heap or a stack grows, the holes will be moved out. The virtual address that includes the holes are known as sparse address space. So this sparse address space is very, very beneficial because the holes can be filled with the help of a stack or a heap segments which will dynamically grow during the execution of the program. The virtual memory will also allow the files and the memory to be shared by more number of processes through the page sharing mechanism. So the benefit of this are the library functions which are stored and shared by the several processes through the mapping can be done only through the virtual address space. Processes can share the memory. The pages that are shared by using the process creation function that is called the fork system call, thus speeding the process creation. Next, the shared library by using the virtual memory. Here the shared library built upon on this layer that is stack, heap, data on code. Shared library will create a new page that is called a shared page that is being shared with the virtual address memory between the two different types of virtual address memory. So the next concept is a demand paging. Demand paging is nothing but this is an alternative strategy to the virtual memory. In this, every process contains very lot of pages. It might be efficient to swap all the pages for a process at once. So the program will act as an application to run over the particular concept and it will be stored in the main memory. So the demand paging is a technique in which all the pages will usually brought into the main memory only when it is needed or demanded by the CPU. When we want to execute that particular process and swap into the main memory, so the swapping the entire process into the main memory, we use the lazy swapper concept. It is nothing but we are going to swap a page into a memory unless the particular page will be needed for the frequent use. Here a swapper will act as a manipulator for the entire process, while the pager is concerned here as a individual pages of process. So this can be explained with the help of this diagram. Here the page memory is divided into contiguous disk space. For example, program A and program B will occupy 4 number of disks. Here the program B will occupy 3 number of disks. Swap out process is done with the help of this magnetic disk. Here the segments has been divided and has been stored. Here the swap out process has been done for the 4 different number of sequence 4, 5, 6 and 7, and the swapping process 16, 17, 18 and 19. So this is how your process is pages is going to be swapping into the memory and swap out of a memory. So by using this demand paging concept, we can easily swap a process whenever the pager requires. The page will be used by the process, otherwise it will be swapped out again. So this page table entry can be considered as a valid page as valid bit and an invalid bit, where one in this memory will indicates that the present condition of a bit as a valid one and the invalid will represents the present condition of a bit as a 0. So like that, we can support this type of hardware system to distinguish the pages that are used in the main memory and the disk. Each page table will be classified into 2 categories. One is a valid and another is a invalid. So this can be explained with the help of this diagram. Here the logical memory has been storing the different number of pages. Here the page table has been created for the particular frame. So this indicates that a particular frame has been related to the address has been valid address or an invalid address. After that, the valid address will be transferred to the physical memory. The physical memory here will convert that particular memory and store it in the logical memory with the help of this magnetic disk. Here the segments has been classified and which are all the segments which we want to swap in and swap out will be done by the particular process creation. After that, it will be stored in the main memory. So this is a concept of demand paging. Moving to the next topic, that is page fault. In a demand paging, a page fault concept is an important one. If a process is going to access a page or that is going to brought into a particular memory, access of the page mark, but when it is an invalid condition of page, it refers to a page fault. For example, if an error condition or a hardware translation like that address will not be matched with the particular pages, like that in a scenario, a page fault will occur. The paging hardware is then translating the particular address that is existing in the page table, that the invalid bit is going to be trapped with the operating system. So this will result in the failure of the particular condition, and the desired pages will not be shared with the memory. So this condition is called as a page fault. So this is a steps that is handled in the page fault. So first, the load page will be stored in the memory. Hence, the pages has been given a reference and stored in the page table. After that, the page table, if the condition is become an invalid one, that is represented as I. After that, the trap condition will occur and it stored the memory in the operating system. So the page is then back to the particular database. Here, the database will access a particular frame, whether it is a valid or invalid one. And it brings about the missing pages information and store it in the physical memory. The free frame will be allocated again, reset the page table with the valid number of bit. So this is how here we have to handle the page fault mechanism. So this is a procedure for handling a page fault. First, we have to trap the operating system and save the user's register and process the date, whether the particular bit or a page that has been used here is interrupted for a page fault like that. Whether the particular check the page reference of a field, whether it is legal or in the location of a particular page. Whether there is an issue while during the disk to a free frame, we should wait for the particular queue for the service. Otherwise, we have to wait for a certain amount of time while transferring the free frame. So the CPU will allocate some of the resources such as CPU scheduling, or it will wait for the input-output condition to occur. After that, we have to save the registers and process state of the particular other users. Then the interrupt has been detected from that particular page. So after that, correct the page table with the other entries by removing the invalid pages and waiting for the other process register to be done. Then the new process is created. Valid pages will contain the valid information without any interrupt sequence. So then it will be followed with a particular condition. So this is a procedure for handling the page fault. So the next concept is pure demand paging. So OS, as we know that OS is start executing a process with number of pages in a memory. Whenever the operating system is going to do that particular process, an instruction pointer to the particular instruction of the process will be given. Here, no non-memory resident pages will be occupied and the process immediately fall for a particular page. After this page, so it will be brought to the main memory. The process is going to be continued for a certain sequence of time until the other pages are needed in the memory. So at the point of this time, it can execute the pages with more number of faults. So this concept is called as a demand paging. It can never bring a page into your memory until it is required. So this is a performance of a demand paging. So the performance of a demand paging can be measured in terms of access time. For a computer system, the memory access time can be varied from 10 to 200 nanoseconds. As long as we have no page fault, the effective time utilization and access time is equal to the memory access time. If a page fault occurs, we must first read the relevant pages from the disk than the desired word. For this, the condition is P is equal to 0, means no page fault will be occurred. P is equal to 1, every reference is a fault. Effective access time is going to be calculated with the help of 1 minus P into MA, that is memory access time, plus P into page fault handling time. So this is how the effective access time can be calculated. So the major three components that are existing in the page fault service time is servicing the page fault interrupt, read the page that is relatively slow, restart the process. So these are the major three components of the page fault service time. For example, we can say that average page fault service time is 8 milliseconds. The memory is going to access the time with the 200 nanoseconds. So the effective time access is going to be calculated with this formula. That is 1 minus P. We are having the memory access time MA as 200 plus P into 8 milliseconds. So this can be calculated with the help of this formula. So these are all some of the advantages and disadvantages of demand paging. So advantages of demand paging are the memory here used are effectively utilized. So this demand paging concept will avoid the external fragmentation concept. So this will be require a low amount of input output condition. So the process here will not be a constraint by the size that is going to be stored in the physical memory. So it can capable of sharing the more number of pages. The portion here used in the process can be never be reloaded. So the no compaction method is used in the demand paging. So the disadvantage is the CPU overhead time will be increased and the interrupt has been occurred and page fault will also be occurred in a frequent time. Memory access time is very longer compared to the virtual memory. The next topic is copy on write condition. It is a main resource management technique that allows a parent process and child process to share some of the pages from the main memory initially. That is called as COW, that is copy on write process. If a unit of a data that is want to be copied but it is not modified, then copy can mainly exist as a reference of a original data. We cannot change or modify that particular data. When the copy data is modified, at that time it's copy created as per the suggested name from the technique. The main use of this technique is to implement the fork system call. That is, we are going to create a new process which we are going to share the virtual memory and the pages of our operating system. The copy on write condition technique is used by several types of operating system like Unix environment, Linux environment, Solaris, and Windows XP. So this is an efficient process for the process creation as the modified pages can be also be copied. So this is a technique that is used in the particular process. The main intention of this process while creating a parent process will create a child process. Both the parent and the child process will initially share the same number of pages in the memory. So that pages will be marked as a copy on write. If the parent or the child process will attempt to modify that particular shared pages, they have to make modification. Only the copy of the page of the process has been done, because the copy should not affect the parallel process which will be takes place. So this can be explained with the help of this particular diagram. Here the process 1 and process 2 are takes place. Page A, page B, and page C are the three pages existing in the physical memory. Here the page A is a parent process, page B and C are the child process. If the parent process and the child process are going to exchange both the process, for example, page B, like, so it has to take a copy of a particular process and store it in a particular process. After that, it has to process or move to the next process that is called as a page B. Making the earlier one of the copy, so it will not affect the process to the other. So this is a condition in the copy on write status. So this in this condition of copy on write technique, we can also use the pages that are modified either by the particular process or it may be copied. So we have going for the duplication of a copy. So here there is a pool of free pages will be there. Depending upon the request of the particular operating system, these free pages are stored in a stack or a heap of a process. They must expand the particular process and they can capable of copy on write of these pages and manage it. These pages are allocating using a technique that is called as zero fill on demand pages. So that means allocating and thus erasing the previous content of the particular process. So this can be explained with the help of this diagram. So here there are different type of pages are there, page A, B and C. Here the physical memory of a page C has been created, copy of a page of a, so this is a duplication of a copy. So it has been stored in a process 1. If the process 2 want to do the same page, so it will be having or access to modify that particular page. So it will not affect the page that has been copied in the process 1. So this concept is called as a copy on write condition. Thank you.